Strengthening energy and community resilience requires cross-cutting solutions, which is why our interdisciplinary team has joined forces to deliver a needed innovation, SPADE, our agrivoltaic design tool. Agrivoltaics is about balance, modification, and landscape integration. It's about optimizing solar configurations, crops, and climate to ensure that we can achieve our nation's clean energy goals and incorporate solar into rural communities responsibly. Providing the tools to know before you grow, SPADE gives developers and farmers certainty and confidence in agrivoltaic development. My name is Alexis. I'm the founder of AgriSolar Consulting. In partnership with Ian and Thomas of Sandbox Solar and Mustafa of Ladybug Tools, we've been working hard to create a solution that supports the growing agrivoltaics industry. Our team has experience in agrivoltaics research and development, software engineering, horticulture, energy policy, and social science, which is why we are so uniquely suited to develop cross-cutting solutions. During this competition, we've upgraded our MVP to a beta version, which we've branded SPADE. With continued AMC funding support, we're eager to incorporate SPADE as a joint venture and provide a solution that unlocks potential at the nexus of energy and agriculture.
SPADE will support Hyperion from site origination all the way through project development. Beyond the agrivoltaic site developer, this tool will inform all project stakeholders, from farmers and landowners to local and state officials. This will provide them confidence in their decision-making process. Hyperion Systems is excited to invest in its further development and use it to expand our agrivoltaic efforts.
Since the start of the AMC Ready phase, we have made significant progress to bring our software to market while increasing 3D agrivoltaic user engagement through our Sandbox Agrivoltaics 3D landing page. This page serves as an educational gateway where users can virtually explore agrivoltaics before diving into the SPADE interface. We have brought SPADE software from a simple back-end algorithm to a fully functioning parametric software application with a web interface that is capable of addressing the biggest questions in agrivoltaic development. SPADE software is split into 5 sections. In the first section, the user can select unique climates or locations through a geospatial map module. The selection of the location cues regional climate data that informs the latter outputs. In the second section, the user can select from various agrivoltaic configurations and module transparency options that best suit their farming needs. Full parametric capabilities will be available on the front end after further software development. In the third section, users can then see PV techno-economic outputs powered by NREL's SAM or System Advisor model to better understand the costs and ROI of their system. In the fourth section, Crop Potential analyzes ground-level photosynthetic photon flux density, or PPFD, below and around the array. PPFD is a measure of photosynthetically active radiation that lands on 1 square meter of land in 1 second. This metric informs the user of the light conditions at the ground level, allowing them to understand which crop families may thrive in those conditions. The fifth section, the Dual Optimum Design Explorer interface, enables users to easily find practical solutions between solar energy production systems and available light for crops. We will leverage this AI technology to find the most economic and feasible solutions for each climate, configuration, and crop type.
The technical achievements just described were driven by an extensive stakeholder engagement process. We leveraged the findings from 30 interviews with developers, farmers, and policymakers to validate market demand and drive improvements in our MVP. Noteworthy accomplishments include a strong graphical user interface and geospatial map module, which makes SPADE more accessible to a broader audience and enhances the user experience. The PPFD outputs are a critical progress point. This metric is more valuable to farmers than irradiance. It gives them a framework for generating a crop plan, which no other solar modeling tool is capable of doing. Our Dual Optimum Design Explorer interface. This allows the user to manage trade-offs between PV generation, crop performance, and costs. This capability is a direct response to our stakeholders' demand. It makes SPADE incredibly unique and will allow our team to sell our software for a premium.
I'm Brian Meerlitz, a software developer on the SAM team at NREL. I've had opportunities to collaborate with Sandbox Solar to integrate PySam into their SPADE Agri-PV design application. Sandbox Solar has demonstrated an impressive ability to engage with agricultural practitioners in order to design a tool to further dual-use deployment of solar with agriculture. Sandbox Solar's GUI addresses a known need in this field, and their development of a crop model supports proposed and ongoing efforts to reduce the complexity of agrivoltaic design.
I'm Tom, and this is Jennifer, and we're Spring Hill Greens. We contacted Sandbox Solar to decide on our final design. We were able to put in a vertical solar fence that gets reflection off of our buildings. It lights up with the morning sun and the evening sun, but during the day we actually get reflection off the buildings that we hope are going to produce a significant amount of solar.
In this phase, we were able to obtain $76,000 worth of consulting contracts from developers and researchers. This supports the market demand for design and consulting, which we estimate as 30% of project CapEx, or $3 billion. 10% of these costs should be obtainable through software modeling and contracts. This supports a $300 million market cap, which we can scale towards. In the last stage, we retired market adoption risks by obtaining revenue and contracts using our tool. We also were awarded a State of Colorado Advanced Industries grant. These funds will directly apply towards expediting the development of the Design Explorer feature in the next 365 days. This is our IP for our premium software business model. This pricing will be discovered with LARTA Institute, an AMC connector. We require the AMC funds in order to support our founders full-time, hire a UX UI developer, and incorporate SPADE LLC. In the next 90 days, our team will attend RE Plus and conduct live in-person demonstrations with key clients to continue software strategy build-out in 2023. We plan on having a product that is ready to scale by the end of 2023, where we plan to raise $5 million to hire 3 software production and 2 sales staff. It is our strategy that we can garner large corporate contracts and partnerships with some of the larger agrivoltaic developers like Baywa, whom we have proof of having strong communications with. Upon acceptance of the AMC grant, our forecasted revenue and business model will be cash flow supported in order to achieve our goals and get to the scaling phase. Ongoing growth will be through an API that can be sold as a service to all other companies to expand our product to other markets that can leverage our data, features, and algorithms. This includes livestock, regenerative farming, and carbon credits, which will help the DOE achieve its solar adoption goals, job creation in underserved farming communities, and allow farmers to make their land more profitable while keeping it agricultural.
By demonstrating to developers, farmers, and investors that agrivoltaics is a viable land use model, SPADE will create shared value for key stakeholders and remove barriers to achieving our nation's clean energy goals. We have a strong team, a robust game plan, and a diverse customer base. We just need the funding support to execute our mission, which upon success will bring manifold benefits to the solar industry, rural communities, the clean energy economy, and more.